You guys tired of hearing my voice yet? Should I change it to something different?
Or maybe I could talk like this and it might be more entertaining. You tell me.
Okay, anyway, we've learned about circles last video. So, can you recall the two formulas up here? So go ahead and try to write those down. Circumference of a circle equals, you should have two choices. You should say pi d or 2 pi r. Area of a circle. Think about it. Hopefully you remember that was pi r squared. Remember, r stands for radius, d stands for diameter, and pi, of course, you always need to use the button on your calculator to get as accurate of an answer as you can. Now we're going to get deeper into circles, recall some of the information we learned already earlier in the semester about circles. So, what do we know about an intercepted arc? Well, we just learned it. An intercepted arc is equal to the measure of its corresponding central angle. How about the length of an intercepted arc? Well, that's what we haven't done yet. But the length of an intercepted arc, is that equal to the central angle? Well, think about that. Measure length. Different words there. So what is the difference between an arc length and an arc measure? Well, first of all, they're measured in different units. For a length, we're talking about centimeters, or we're talking about meters, or we're talking about feet, or we're talking about inches, right? For an arc measure, we're talking about degrees. What else is different? Well, because we're measuring in these kind of units for length, we're kind of referring to a distance. It's going to be related to the circumference of a circle. Right, so it's related to the circumference, the outside edge of the circle, as opposed to the arc measure, which is really it's related to the central angle, which is that angle measure. Right, so it's all about the angle measure, or degrees. So here we have it, if this is a 72-degree angle, then the arc measure would be 72 degrees. That's the arc measure. But the arc length, well, we wouldn't say the distance from A to B is 72 degrees. It doesn't make sense. So instead, we would give that a certain value in terms of distance. Now look at this. In a true-false question on the test, you were asked about, these arc measures. Is the arc measure of CE the same as the arc measure of AB? Yes, it is. Even though this is a smaller circle, a bigger circle, these arc measures are still the central angle. However, the arc length, clearly, the arc length of CE is smaller than this arc length. Because arc lengths are measuring distance around that edge or the circumference, obviously the smaller the circle, the smaller the arc length, the bigger the circle, the longer the arc length. Okay, what is the piece of pie or wedge called in the circle? So what would we call this little piece of pie right here if I were to color that in? Remember, we call that a sector. If you forgot, there's another vocabulary word to help you. Oh darn, my measurements didn't come out properly, but that's okay. You guys have them correctly on your paper, so I can just fix it here. It says, investigation, determine what fraction of the circle each arc is. So, if this is an arc right here, obviously this is a 90-degree angle. So what fraction of the circle would that be? Well, if that's 90 degrees, it's 360 degrees all the way around. So obviously that is a quarter of the circle, 1/4. Here in the semicircle, what about arc CIJ? So that's a semicircle. How do I know that? Because this is a diameter right here. So what fraction is this sector? This is going to be half of the circle. And then we have OM. Okay, it looks a little more complicated, but is it really? What's my pattern? What am I doing here? Here I took 180 degrees divided by 360. Here it was 90 degrees divided by 360. Here I know the arc measure is 150 degrees. Out of what entire portion of the circle? Out of 360 degrees. Well, 150 and 360 are both divisible by 30. So this is 5/12 of the circle. So any questions on how to get what fraction of the circle? You just take the angle that's associated with that central angle, or the arc measure, and divide it by the total one revolution around the circle, which is 360 degrees. Okay, now what if I asked you to find the circumference of each circle? So let's pretend here that this length is 12 units. Then what would the circumference be? The circumference is 2 times pi times r. So the circumference is just 24 pi. For CJ, if the I gave you the diameter this time, so that's just going to be pi d or 8d, right? So CJ, I gave you the diameter, so be aware of that. So it's just pi d or 8d. For letter C, I gave you the radius again, so that's twice the radius times pi, which is 72 pi. So here are my three circumferences. Now it says combine steps 1 and 2 to find the length of each arc. Well, if we know that this is 1/4 of a circle, and this is the entire circumference, well, what am I going to do with these two values? I'm just going to multiply 1/4 times 24 pi. Therefore, arc FH, the length of arc FH is 6 pi. So notice I don't have a measure in front of here. The measure in front of there indicates what kind of angle you want, the angle in degrees, or sorry, the arc measure degrees. This is now the length of arc FH, and that's 6 pi. So do the next one. Well, this is half of the entire circle. So the entire circle circumference is 8 pi. So obviously we're going to take half of that, which is 4 pi. So arc CIJ has a total length of 4 pi units. And finally, this last one, we said this last one was 5/12 of an entire circle. So we're going to multiply 72 pi times 5/12. So you can just use your calculator and do math frac, or you can do 12 goes into 72 6 times. So that portion, or that length around here for MO is equal to 30 pi. So what did I do? I just took the fraction of the circle, so you take the degrees that was given, divided by 360, multiplied by the circumference. 150 divided by 360, multiplied by the circumference, and that gives you just the fraction of the entire circle that we're talking about. Now how can we find the area? Again, leave our answers with pi. Sorry, I didn't emphasize that before. So the area, well, it's the same thing, right? It's 1/4 of the area of the circle, and the pi r squared is the formula for area. So I just multiply 1/4 times 144 pi, and I get 36 pi units squared. The area for CIJ is going to be 1/2 pi r squared. Well, remember this was the diameter, right? The diameter was 8, therefore the radius was 4. So you have to go back and take 4 and square it. So that's 16 times 1/2 times pi, which is an area of that sector, which is 8 pi units. And finally, this last one, we're going to take 5/12 and multiply it by pi r squared. Sorry, oops, put the wrong thing here. So I believe that comes out to 540 pi, but again, check it. You guys are good at checking my work and telling me when I do something incorrect, which is very good. It means you're practicing them yourselves. Don't rely on me, I make mistakes. So if you don't understand, we're just taking a fraction of the circle. But instead of finding the entire area, we're just finding this portion of the area, right? Which we identified through its angle that was given. Instead of taking the entire area, we just find this portion of the area by taking the fraction of it according to the angle. Ask me in class if you're not following, so we can discuss it. Okay, moving on. So what are the general formulas for arc length and area of a sector? So what did we do? We took the given angle divided by 360 degrees and multiplied it by the circumference, either 2 pi r or pi d. We took the given angle divided by 360 degrees and multiplied it by pi r squared. And then you have to say, well, what does x represent? I guess I should put where x is the, what do we call that again? Hopefully you're saying either central angle, or you could also write arc measure. So you should remind yourself what x is by writing this sentence. So I just wrote where x is the central angle or the arc measure. So here's some more practice problems. You might want to pause, try them on your own, see how you do, and then check my solutions when you're done. So go ahead and pause now. Okay, this is good practice for digging back into that circle unit and what we learned about central angles and inscribed angles. So it says if the radius of the circle is 24 centimeters, so we know this is 24 centimeters, and the measure PQR is 60, which is an inscribed angle, what is the length of arc PR? So we're trying to find this. Well, if this is 60 degrees, we know that the central angle is double that, or the arc measure is double that, which is 120. So then we're taking 120 over 360 degrees times 2 pi r, right, times 2 times r times pi. So you should reduce that. This goes 1 into 3, 3 goes into 24 8 times, 2 times 6 is, or sorry, 2 times 8 is 16. So your answer should have been 16 pi centimeters. So 16 pi centimeters. The length of the arc shouldn't have any units squared there. Okay, number 2, again, like you took a couple of different steps you had to do. First, you should have noticed that this arc measure, RT, was 120, which meant the arc measure ROT is 360 minus 120, which is 240 degrees. And then we had to set, they gave us the length equals 116 pi, so I'm setting that equal to x over 360 times 2 times pi times r, but I'm trying to find r. So when I do this, my pi's cancel, so I want to show you this work here. 240 divided by 360 reduces to 2/3. So this becomes 4/3 r equals 16. I have to multiply by the reciprocal, which is 3/4, right? And so I multiply the reciprocal by 3/4, and 4 goes into that 4 times. So I get 12. Or sorry, oh, this is 116, not, there you go, another mistake. I didn't put the answer there to remind myself. I don't like the color orange either. And I'm running out of time. Okay. So the pi's cancel. Oh, darn. Pi's cancel. Pi cancels, I have to multiply, this is 4/3 r. I have to multiply by 3/4, these cancel. Multiply 116 by 3/4, 4 cancels that 29 times. 29 times 3 is 87. So you should have gotten an answer of 87 meters here. For number 3, we're talking about areas now, which is pi r squared times the fraction of the circle. So it's only 45 degrees. You should have done 45 divided by 360 degrees, that fraction of the circle. The radius was 20, so that's just times pi r squared. And then you multiply all that out using your calculator, and you should get 50 pi centimeters squared this time because we're talking about area. For number 4, they gave us the area, so I'm trying to find this value here, the arc measure. So I take x divided by 360 times pi r squared. My pi's cancel, and this becomes 36. 36 goes into 360 10 times. Then I just cross multiply 14 times 10, so you should get 140 degrees. So number 4 is 140 degrees. And finally, number 5, the region bounded by a chord and its intercepted arc is called a segment. So this red area is the segment. Find the area of the segment enclosed by xy and arc xy if the radius is 10 centimeters. So you should get 25 pi minus 50 centimeters. So try that. First, you have to take the area of the sector, which is that whole piece of pi, right? So that's this right here. Take the area of the blue. Then you're going to subtract the area of the triangle. This triangle, if I put that O there, triangle XOY. And when you do that, so this is obviously the area of the sector, area of the triangle, and that's your answer. Ta-da!